All right, so I got some code here. This is a follow-on to this AAC algorithm that I did the other day. So if you recall, I had this AAC algorithm, and it sort of like loops through all of the different. I'll just run it again to kind of show you. It runs through the data that's received. So this is the high E note. So this is the circuit playground, and it's using the mic.record element to record a sound. And this is Intonian, so this is previously recorded data. And so if you open up you gotta go to all files here, or text files, I guess, and you go to the raw data. This is a text file just of raw bits, and there's 6 rows, and so it's EADGBE. And so this code is looping through all of the different notes. So for X in range 0 to 6, it's looping through all those notes. And what it's doing is it's computing this correlation index. So this is the low E string, and so you can kind of see there's a fundamental frequency there. And it runs through this correlation function. And I went over this in the last video, and so I don't want to spend too much on this because unfortunately my student is trying to put this code onto the circuit playground, and what's happening is, oh gosh, isn't there like a close all? That would be, oh wait, yeah, can't I just stop it? Yeah, okay. So what I did was, what the student is running into is that when he runs it on this code here, there's a while true loop down here. So here's the mic.record where he's setting up the mic. And basically, if the counter is 0, it displays a RGB blue pixel there. And basically, if you hit the tune button, it switches to a different note. And so what happens is that the memory allocation here fails. It tries to allocate some bytes, and it can't do it. And it says that it happens on line 134 right here. So the issue here is that this line of code here is allocating like a new array. And so what needs to happen is we need to like allocate all of the variables like at the beginning. Like even here, we have like YK vowels as array. Like there's no way that that's going to work. So this is actually a pretty complex issue to resolve, because the problem is that like you're trying to run the neopixels and things like that, and this neopixel block is probably rather large, and so is this tune button and the next button. These are definitely taking bytes from memory, and so it's possible we have to drop down the sample rate. So what I'm going to do is I'm going to pull this buffer out, and so I only want it to declare once, and let's see if it so it fails to allocate right off the bat. What I'm wondering is like, it hasn't called this function yet, but I'm wondering if it like pre-allocates this function, like if it packages this function up. And so what I did was I have this code over here in Tony called low bytes, and what I want to do is I want to see if I can get this code to work with lower bytes. And so the biggest thing that I want to get rid of is this NP zeros. And so I want to say, I just want ZK vowels to be here and here, and just make those equal to 0. And I don't actually want to save those values. I don't even want to plot. So like, down here when I return, I don't even want to return the ZK vowels. I'm okay returning the segment because that you need to do everything. But other than that, I don't want anything else. So I'm going to get rid of ZK vowels and YK vowels here and just spit out this. And then I'll plot the segment, that's fine. But I'm not going to plot any of this. I'm not actually going to plot the correlation function. I'm just going to spit out the frequency. So if I run this is going to break immediately because it's going to say like, sorry, you can't do that. And so basically I need to go through the code here and figure out, make sure I'm actually recording here, and I am good. So what I want to do is I want to go through this code, and everywhere where I set ZK vowels of K to something, so here, like I just want to get rid of that. Okay, so I just get rid of that, and then this is all fine. I want to get rid of this savings. So then now, instead of ZK vowels of K, I just need to do ZK is greater than or equal to yk and get rid of the element y's. And then instead of the element y's here, just do yint as yk. And then zk max, same thing, change this to zk, and then change this to zk, and then this to zk, and then this to yk. And then I want to say that's it. So if I run that and hit go, of course there's some invalid syntax, there's a semicolon there. Okay, cool. So I'm plotting the segments, which is fine, and honestly I think I'm going to get rid of that plotting statement too. And just get rid of that and just say, don't even do a plt.show. Okay, so there you go. So it's just the frequency, and then I'm going to even make it even simpler. I'm just going to have it spit out the frequency like so, and then go back to this return element and just have it spit out the frequency like so, and run it, and there you go. Okay, cool. So that wasn't very many changes to the code. So I'm not, instead of copying this over, instead of copying this over, I'm just going to implement this on this code. So I know this is like bad habits here, or like bad coding practice. Like really what you should be doing is if you're doing like hardware in the loop, you want to take your code that you're running on your computer and perfectly copy it over. But for now, I'm just going to leave it. So I don't need this ZK vals, and I don't need this ZK vals or YK vals, sorry. And then everywhere I see a ZK vals, I just change to the appropriate element. Okay, so that gets rid of that, that gets rid of that, that gets rid of that, that gets rid of that. Okay, and then this gets rid of this, and then this gets rid of this. Okay, then I just return the frequency. So I mean, the student did a pretty good job, like getting the code cleaned up. But at least we don't have to declare that array. Okay, so it looks like we're still running into some issues here. So I guess I probably need this entire library import array. But do we need everything from these imports? That's an interesting idea. Like you see how it says from digital IO import digital in out direction pull. Like I wonder if we're using this time object. Let me pause my video here real quick. All right, where was I? I was looping through here and taking a look at this and realizing that the frequency was all good. Oh yeah, I was saying like time. Like what do we need from these import statements? Like where is time? Is time even used? It doesn't even look like time is used. I'm gonna get rid of it and see what happens. Let's see. And okay, it looks like it worked. It's bugging out on line 115. So it's really having trouble with this sample size thing. How big is the sample size? 3,203. What was it over here in Tony? What was the size of the data set? I guess it doesn't really tell you. If I do data np.shape of data. What? 640. Is that right? So wait, why don't we just make this like 1,000? It works now. Tau is not defined. Where? Line 66? You're supposed to define tau here. You give it 50. What's 50? The lowest frequency? Shouldn't that be like a variable? I feel like that should be a variable. Okay, so should we just make tau a global? Let's just make tau an input. And then what we're going to do is if counter is equal to 0, I think we should comment this. Like, which are we tuning? Are we tuning the low E? The ref frequency is 82, so this is low E. So print low E, and then tau equals, and let's go back to Tony. Tony is let's see, tau is what, 20 over 1,000. Oh God. Let's not print low E. Okay. Anyway, let's hit the. What is the other button? So the next button is B, right? Let's see. So we've got the A button and the B button. So if I hit the, is the next button even coded? Next button's not even. Okay, so this code's not quite done yet, which is fine. Let's just see if we can get this memory issue working. So let's see. So I broke the code because I didn't give it tau here. Okay, so then we're gonna hit. Did I do it? Oh, you know what? This tune value equals true. Like, I feel like you want to do a toggle switch. You know what I mean? Like, I think what we want to do is we want to say, like, if tune button dot value equals true, tuning equals true, and then let's do a time. Okay, so I'm gonna pull time back in because I want to sleep. I actually literally want to sleep. I am exhausted. Time dot sleep. Having 3 children is not a recipe for sleeping. So then what I want to do is I want to say if tuning equals true, and then what I want to do up here is just say, tuning is false. Tuning equals false. But what I want to do is instead of doing equals true, I want to see tuning equals not tuning, right? So it toggles, So I'm gonna hit it. So let's print tuning, okay? And then I'm tuning. That's the A button, right? A button, yeah. I'm tuning. Let's print tuning. Oh, whoops. So I hit the A button, true, tuning. And is it just taking that long to run through this loop? That's possible. Let's say print recording signal. It's possible the CPX is just really not sample recorded. Okay, and then we're going to say print frequency equals frequency. Let's see if this even does. So the sample's recorded, so it's running through these frequencies, so it's just taking a long time to compute all this. Is there a break anywhere? There's a while k is less than len data minus ms, and ms is up there. And I mean, it's 1,000 data points, right? But it has to loop through, it's like 1,000 times, right? Maybe we should do 640 like it was doing on the computer. And I guess let's print k. So I'm going to print k, comma, len data minus ms. Actually, I'm going to print len data ms and then len data minus ms. Yeah, that's what I want. Dude, so that needs to get up to 320. That's a long time. This code, man, or this CPX is not fast. I mean, what are you going to do? Pluck a string and there it goes. Oop. I ran into an error. unsupported, so line 148, and look at that, I got the frequency was 0. Oh, I didn't actually like play a string. Okay, so you need to do, I don't like this like spelling out counter. Where do you define counter? There it is. You know, I like CTR. It's easier to spell. And then let's see, counter, and can you do switch cases in Python? Because that would be boss. Two simple ways. The answer is no. Yeah, see, that's C. I don't want you to tell me. Oh, what the heck? No, dude, don't do that. That's okay. Forget it. We're just doing this. Switch case would be boss. Oops, that's not what I want. Why is this 5? This should be 6, right? This should be 7. Okay, and then here, so ref frequency, this needs to be counter, because the error that it threw before is that this ref frequency is a tuple, and this ref frequency is not. Okay, so we're tuning, and then we wait 320 seconds. This is ridiculous. I mean, it's literally, it's because of this loop here. You know, if these were numpy arrays, we could just multiply these together. I wonder if we could vectorize it. Let's do that. Let's see if we can vectorize it. So let's get rid of that print statement. Where's that print? Is it down here? Yeah. No, there's a print K and yeah, up here. All right, let's see if we can vectorize this. So what I'm going to do is I'm going to say ZK is segment of M times, 1 to MS. How does this work in Python? I always forget. Python A equals so if I want A of 1 to 2, that just gives me the second one. If I do 3, it gives me the last 2. Okay. So if I do 1 to MS plus 1 times data of 1 plus K, because I need to offset to 1 plus MS plus K. And then comment these out and pray that it lets me do this. Blast. Unsupported types for mul array. So how is it doing this? It's importing the array block. So if I import array and I make A equal an array dot array of 0, 1, 2. Takes at most 2 arguments. Can I give it a list? How does it do it here? Oh, okay, you have to give it 2 arguments. Okay, so this is saying give it a hexadecimal. There we go. So there's A. And then let's make A equal B. Oh, B equals A. And A times B. Yeah, so I don't know. I guess we can Google this. I don't want to Google while I'm not going to Google while I'm on here. This is going to take too long. All right, I Googled for a bit and I found nothing. So I found a couple things, but basically you can't do this like array multiplication, which sucks. Because it means that this is just going to take forever to do its thing. Because of this loop right here, basically you know, looping through and multiplying these vectors together. It just takes a long time to, you know, the sampling is like instantaneous, but then the multiplication is, you know, it takes forever. Oh well. I mean, I guess we can try to make it a little bit faster, you know, but I mean, we start bringing this down to 320. Oh, yeah, that's actually pretty fast. Let's try 400. Let's get rid of this tuning. Oh, I see what's happening. The length of the segment is 320. So okay, yeah, so len data minus ms is 80, so it just needs to run through 80 frequencies right now, or 80 jumps. But if you make this equal to 320, it only has to loop through once. And so when you hit tune, it's like almost instantaneous. Anyway, so we just hit that, and we hit frequency. When we hit that, and we get a frequency of 0. I mean, there's no way it's going to pick up the frequency. It's running faster. So you do 330, and it's going to run through 10. Let me get rid of that print statement. Frequency. I'm going to grab my guitar and see if this works. Alright, so here we go. So I'm plucking a string here. Get nothing, 0. Let's make this 400 again. See, now I have no idea what it's doing. I got a frequency of 0. Yeah, I mean, this is just, I don't know, man. I think the post-processing is really cool, you know, running through this super fast, but I mean, you're talking about a processor on a computer versus a processor on a CPX, and I think we're just running into serious limitations here. So, yeah, all right, well, I debugged as much as I can. I think I'm gonna stop here. I don't even think I'm gonna upload this video, honestly. But if I do, happy coding.